Welcome back to my lecture on probability and statistics. In this section, we're just going to be talking about the law of large numbers. So we're going to be talking about the weak law of large numbers. The strong law is similar, but stronger. So for the law of large numbers, we need to understand that we're discussing a limit first and foremost. So what we're saying by this limit symbol is we're saying something is going in a direction, something is in movement. So we're going to say n, which is our sample size, is increasing. That's not an infinity, is increasing. So all this simply means is that we're taking a larger and larger sample. And now we're going to talk about a probability between the distance of the sample mean and the population mean. Okay, we're saying that the probability that this distance is less than some arbitrarily small number is the limit as this gets larger is equal to 1. So what we're really saying here is that as our sample size approaches the population size, the probability that our sample mean is equal to our population mean is converging to 1. The probability is converging to 1. So in our last example, we had a set and it had 2 red marbles, it had 3 green marbles, and it had 1 yellow marble. And what we're going to talk about here is the population proportion of green, and that's equal to 1/2. Okay? And so what the law of large numbers is saying is if I take a sample size of 1, right? A sample size of 1, my S1 is equal to, I'll just say I grab a green at random. This is my sample size of 1. So my population proportion, P hat population proportion is going to be equal to 1, right? And so by the law of large numbers, I have X of X bar, so the mean population proportion, So the sample population proportion for green minus the true population proportion, right, is in distance equal to 1/2. So this epsilon symbol here represents an arbitrarily small number. So what we're saying is that in a sample size of 1, this distance is getting smaller. So now let's pick a sample size of 2, and we're going to have a green and a red. Okay, and so the population proportion of green now in this sample space is equal to 1/2. So it's getting closer. Now, even if it were 2 green, so S2 could be equal to green, and it would be the same. S3, we'll just say for arguments purposes, green, 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 just to make it annoying. So now my P hat green, or my population proportion estimate, is still equal to 1. So it's 1, now it's 1/2, now it's back to being 1. And so this is equal to, green, green, this is now equal to 1/2 minus 1/2, which is equal to 0. But now we're back to the original green minus probability green, or population proportion green is equal to 1/2 of green. Okay, so we're going to increase it again, S4. Now we have a sample here, and we have to grab 4. It doesn't have to be the same number of greens here. But what we're going to do is we're going to grab green, green, yellow, red. And now we're back to 1/2. And 1/2 gives us, we'll do a ... 0. So we're at 1/2, 0, 1/2. It's oscillating, but let's go to 5. And at 5, we can have 3 greens, we can have a yellow, and we can have a red, but we're out of greens. So now the estimate is equal to 3 out of 5. And so now we're going to have to do 1/2 minus 3 out of 5. So this is going to be equal to, we'll just do this like this, 6/10 minus 5 out of 10, which is equal to 1/10, right? We want it to be 0. And sometimes we hit 0, but this, now when we get S6, it has to converge. And that's really the point of the law of large numbers, is that it has to converge. And then now we're at 0. It has to converge. So the law of large numbers states that as the sample size approaches the population size, the probability that the sample mean will become the population mean, that probability of convergence is equal to 1. And when you apply it to population proportions, it does the same phenomena. So you can think of it as in the population probability is converged to by the sample probability as the sample probability has more samples.